Today we're going to review going over questions. We started this on Friday, but then we took a detour to do the test retake yesterday. So yesterday's homework is here, and we'll discuss that in class and go over any questions you have. And for right now, I'm just going to review what we did and the steps. Okay, so these are the steps to solving polynomial equations. First, we have to get that polynomial equal to 0. Okay, sometimes it is already equal to 0. If not, we may have to do some addition, subtractions to get it equal to 0. After that, we work on our factoring. Remember all of our factoring methods. We start with our GCF. Always do that first. Look for one of those. And then we decide if it has 2 terms left over, 3 terms, or 4 terms, and then we use the appropriate factoring method depending on what the case may be. Next, we set each of the factors from step 2. So now we've got it all factored. It's going to be a bunch of binomials, and maybe there might be some GCF out front. We just set each one of those individually equal to 0. And then lastly, we solve each of those little equations. So let's just review a couple. Now, I've got the polynomial that we're trying to solve written right here, and it's already equal to 0. I've also gone ahead and I've graphed it over here to the right so you can actually see the solutions we should get if we do it correctly. Okay. Now notice these, and you may ask, why don't we solve everyone by graphing just using Desmos? Well, you can see that this doesn't give us an exact answer. This is negative 1.732. The y value is 0. That's why we call these the zeros of the functions. These are also x-intercepts. This is our x-axis right here, and this is where our graph, the red line, crosses it or touches it. And so this first solution, we don't know if it has more decimal places or not. This 0 looks like a perfect solution, so x is 0 would be an answer. And this solution is, let's see here, this one right here, it's hard to see that 0, see if I can zoom in a little bit. This 0 right here is this 1.732, again probably rounded, and then this 0 right there looks like x is exactly 2, so that is a perfect solution. Okay, but those rounded ones are the ones that we cannot get from a graphing calculator. So let's look at our first step here. Step 1, I'm going to write the steps off to the side. Step 1, get equal to 0. Okay, and that's already done. It already equals 0. Step 2, factor. So let's look for GCF here. It looks like we can take an x out. X cubed minus 2x squared minus 3x plus 6 equals 0. Let's see. Now, at this point, we do have it factored partially. In this x, we just got to keep track of him. Okay, don't lose track of him. But now we're going to focus on factoring what's left over. So that's x cubed minus 2x squared minus 3x plus 6. We can see it's got 4 terms. So let's group it. Remember, we capture the negative inside. We GCF, take an x squared out, take a negative 3 out, and we can see our common factors here are x minus 2, so we pull that out front. When we take it out of this first term, we're left with an x squared. We take it out of this second term, we're left with this minus 3. And I'm going to bring this x down. So there is my complete factorization. Now I may try to factor this x squared minus 3. It's 2 terms. It's x squared. It could be a difference of squares, but 3 is not a perfect square. So that is step 2. We've completely factored it. Let's go to step 3. In step 3, we're going to set each factor equal to 0. So here's our first factor, x. We set u equal to 0. And see, this equation already tells me what x is. X is 0. The second factor, x minus 2, I set him equal to 0. He doesn't tell me what x is yet. I have to do a little work. I add 2 to both sides. X is 2. So there's my second answer. And then my last factor is the x squared minus 3, and I go x squared minus 3 equals 0. And to solve him, he's quadratic. I'm going to add 3 to both sides, and I can just square root both sides. And x equals, remember, we always get plus or minus square root of 3. And that's answers 3 and 4. So our final solutions are x is 0, x is 2, x is a positive root 3, x is a negative root 3. Okay, and if you get out your calculator and check to see what root 3 and negative root 3 are, root 3 is approximately equal to negative 1.732. And, oops, that's a positive one, and the other one would be the negative 1.732. Okay, but again, those are approximations. These, when we write them with the square root in them, those are exact answers. Okay, if I plug in root 3 into this original function, it would give me 0 exactly. If I were to plug in these approximations into this function, it'd get me close to 0, but it wouldn't be exactly equal to 0. So approximations aren't true solutions, they're just very close to the actual solution. And when we're doing mathematics, if we can get the exact answers, we want those. And so you can see we do match up with what our graph showed. We got the 0, we got the positive 2, and then our 1.7 and our negative 1.7. So we found all of our solutions. I guess I should have put that as step 4. Step 4, solve each equation. And that's what we did in that last step. Alrighty, so that's it. Now, yeah, it takes a long time to explain, but it really doesn't take that long level of factoring. Let's look at this example right here. And again, I've got the graph shown over there. You do not have to show the graph. You don't have to graph it on Desmos, but it certainly is a great way to check your answers, to throw it into the graph, click those zeros, and see if yours match up. So without writing down the steps this time, because we've seen them a number of times, we've got it equal to 0. Great. So now let's start factoring. We check for a GCF. It looks like an x squared can come out of everybody. X cubed minus x squared minus 2x plus 2. I've got my first GCF out there. I'm just going to keep track of him. And I'm going to group the 4 terms that are left over, or regroup. Take out an x squared here. Take out a negative 2 here. So there's my common factor that I can pull out front, leaving me with an x squared minus 2. And I'm going to bring that x squared down to make sure it's all equivalent to the original polynomial. So I've got it completely factored. I just set each factor equal to 0. And I like to do this all in one step like so. So I'm going to group in my processes. And then I'm going to solve them. And here I have to square root both sides to get x equals, and you always get plus or minus. So we get 2 solutions there, plus 0, minus 0. Well, that's both zeros, plus 0, minus 0, the same thing. This is essentially 0, 0, or 0 with multiplicity 2. That just means it happens twice. And you can see we talked about this on Friday. Multiplicity, and what that means graphically is that our graph just comes down, hits it at 0, then starts to turn away. And whenever it just touches like that and turns back upward again, or if it came from the bottom downward again, we get multiplicity. Our next equation here, we add 1 to both sides, and we get x equals 1. So we have those two solutions. We have x is 1. Let's check it. Yep, there that one is. When x is 1, y is 0. And then our last, here we go, our last equation, x squared minus 2. So we'll add 2 to both sides. We'll square root it, and we get x equals plus or minus root 2. And that's 2 more solutions. So our final answers would look like this. X equals 0, and we can just put m2 for multiplicity of 2, the number 1, positive root 2, and negative root 2. Now you could put that as just plus or minus root 2. I'm just trying to emphasize those are actually 2 solutions. And it turns out root 2 is approximately equal to 1.414, and negative root 2 is negative, approximately negative 1.414, and that's these solutions. And then our 0 there with multiplicity. So all of our solutions in exact form. And we're done. Depends on your next problems are again solving quadratics, but they're in what we call quadratic form. And notice in quadratic form, now this isn't the only type that's in quadratic form, but quadratic forms, you're going to see a pattern where you've got the first exponent is 4 and the second exponent is half as much, 2. You'll also see some occasionally where it might be like ax to the 6 and bx to the half of 6 would be 3. Okay, so if you see this where it's double, and see our quadratic equations, ax squared plus bx, follow that same pattern, where 2 and then half of 2 is this 1, and that's why we call it quadratic form. And I don't want to go too far into the woods here, but we can actually take a polynomial that has that pattern, and we can write it as something squared minus something to the first power, like that. So it goes 2, 1, no x's, just like our quadratics do. And so this is called quadratic form, and they aren't a big deal, except normally if we're solving a quadratic like this, quadratic, remember, is x squared, it always starts with x times x. Well, if it's x to the 4th, it starts with x squared times x squared. Okay, so our first step to go into solving this is it does equal 0. Okay, now we try to factor it. Because it starts with x to the 4th, we got to go x squared and x squared. And then we can just do our r and s thing again. Okay, so we're trying to get a 4, so it's either 1 times 4 or 2 times 2. It's got to add up to a negative 5, the b term in the middle. So it's got to be the 1 and the 4, but they both better be negative. Okay, those two still multiply to a positive 4, the c value, but now they add up to negative 5, the b value. So we know it's going to be a negative 1 and a negative 5. Oops, negative 1 and a negative 4 in here. Now, at this point, you got two choices here. You could set each factor equal to 0, and they would solve with the square root method. Okay, or we could notice these are both differences of squares, which I think would probably be the easiest. X minus 1, x plus 1, x minus 2, x plus 2, and we set each one equal to 0 and solve them. And those are way too crowded there. I should have done something to separate them. There we go. So there's our 4 equations. And we add 1 to both sides, so x is 1, subtract 1, x is negative 1, add 2 to both sides, x is 2, subtract 2 from both sides, x is negative 2. So our solutions are, we could write it this way, plus or minus 1 and plus or minus 2. That's the same thing as just listing them singly like that. And we can see over here in our graph, indeed, those are our zeros. And in this case, had we graphed it ahead of time, it would have told us all the solutions right away because they're all nice integer solutions. But we need to practice solving by factoring because that works a lot of the times, not all the times. Next example, this time I don't have the graph, although I'm going to show it after we see if we have found some answers, and then we'll check it with a graph. So I notice it's in quadratic form, 3 terms. It's a 4, then a 2, half as much. So it equals 0 already. I just go x squared and x squared. I have to get 21. So it's 1 times 21 or 3 times 7. They have to add up to negative 10. So if they're both negative, they add up to negative 10 and they multiply to positive 21. So now I know it's got to be a negative 3 and a negative 7. And then I can drop down and I just set each factor equal to 0. Now these, I could have tried the difference of squares on, but 3 is not a perfect square and 7 isn't. So we're going to have to use the square root method. X squared equals 3, and we square root both sides. X equals plus or minus root 3, 2 answers. Take the 7 over by adding, and square root both sides. X equals plus or minus root 7. 4 answers. Root 3, negative root 3, root 7, negative root 7. These are all irrational. Okay, these are, if you hit that in your calculator, it's a decimal that never ends and never repeats in a pattern. Let's take a look at the graph. Get that on the next slide here. This is our approximations. This is plus or minus root 3, and this approximation is plus or minus the root 7. And you can see over here in the graph, there's our plus or minus root 7s. These are plus or minus root 3s. And our calculator, our graphing with Desmos, did not give us the exact answers. And so we would have had to have done this in the method I showed with factoring. That's it. It's pretty straightforward. Okay. You've got a couple of polynomials here at the beginning that you're supposed to solve. These I think you can both take a GCF out of. And then these last 3 are those that are in what we called quadratic form. So you're going to have to factor them as an x squared quantity times an x squared quantity, both of those being binomials. So, and again, remember, you got to get them equal to 0 first. Okay, so move stuff over to the left-hand side with addition and subtraction. Combine any like terms you have, and then it'll be equal to 0, and you can start factoring the problem. All right, that is it. Everybody stay up with your homework. It's getting tougher.